particular curriculum framework came up. This has a core curriculum.
My dear students, other viewers and listeners, I, Professor Manohar Lal, Director, School of Computer and Information Sciences, IGNOU, welcome you to this lecture on sorting algorithms and asymptotic notations. Friends, in our previous lectures, we have already talked what is an algorithm. I just summarize that an algorithm is a method which can be executed by a computer system when expressed in a notation which is known to the computer system, that is in a programming language. In finite amount of time, it has a sequence of instructions. Each instruction must be executable in finite number of times. It may have 0 or more than 1 inputs. However, it must have at least one output, and some other restrictions on a method make it an algorithm. Then we also discussed that why algorithms are used in computer science and what are the limitations of algorithms in solving problems. We mentioned that the main method of solving problems with the help of a computer is algorithmic. However, it was also mentioned in our previous lectures that the algorithmic approach is limited in the sense that not all problems which we human beings may encounter can be solved with the help of algorithmic methods. But still, algorithmic methods form the central or most important problem solving methods in computer science. So friends, with this introduction, now we'll come to actually writing some algorithms for solving problems. In this respect, sorting is a very important or very common phenomena in a number of applications, and therefore, to begin with discussion of actual algorithms, I'll start discussion of sorting algorithms. Friends, there are a number of sorting algorithms which are well known, and because there are more than one algorithms which exist and are used, this means no one particular algorithm is good enough to solve all problems better than any other algorithmic method. So anyway, before we go into the discussion of various algorithms for sorting, let us have a brief look. What is sorting? So please, sorting refers to the operation of arranging data items in some order which is defined on the domain of the data items. What does this mean? That suppose you are given a sequence of numbers. Then arranging the numbers either in increasing order or decreasing order is called a sorting method. Similarly, when you are given a number of names, then if we arrange the names in a dictionary or lexicographic ordering, then it is another way of ordering or sorting the names. So friends, arranging given list of items in some order is called sorting. A similar concept is that of searching. However, searching is a bit different concept in the sense that already the list is given to you and you have to find out a particular item. If the list is already sorted, then the search becomes very easy. However, if the list is not sorted, then in that case searching becomes very difficult. You may take the example of telephone directory. If the names are not arranged in lexicographic order, that is all A's preceding all B's in specific positions and all that, then finding out a particular name will become very difficult. So if the names are already sorted according to dictionary ordering, then finding out a name becomes quite easy. So that is, you can see, one of the major application of sorting. And with this introduction to sorting and the related concept of searching, let us go to number of algorithms which are used for the sorting purposes. Please look at the slide. As I mentioned, there are a number of well-known sorting algorithms. Just to name, one is insertion sort, the other is bubble sort, the next is selection sort, then the shell sort, merge sort, quick sort, heap sort. These are not all the algorithms which are used for sorting purposes, but these are the major ones which are used for sorting purposes. And as I mentioned earlier also, if so many algorithms for sorting are there, this means none is the best in all situations. That is, they may have their relative merit or advantage for sorting particular lists, may not be that good in some for other lists. So friends, one by one we will discuss each of these algorithms through, first of all, to explain any of these algorithms, we'll have some example. Examples are drawn from numbers or integers. Then the method is first of all explained through the example, and finally the algorithm is written in a pseudo coding programming language. So let us go for the discussion of the insertion sort. Insertion sort, briefly, what we do, we pick up numbers from left one by one and put the newly picked up number at its relative position among the earlier order ones. Well, the description may not be very clear, we will come back again. However, when we consider a particular example, in order to explain what is the insertion sort, then it is quite easy to understand the algorithm, and we will come to the description afterwards. Friends, for this purpose, we will have a list which is not in a sorted order, and then we will explain the various steps of insertion sort in this particular case. By using the various steps, the sorting algorithm increasingly gives the more ordered list as compared to the initially we started with. So let us have a look at the slide. In the slide, the first row has a list of 6 numbers. Initially the numbers are given in the list 80, followed by 32, followed by 31, followed by 110, followed by 50, followed by 40. So you can see yourself, for example, 80 is more than 32, and 32 is more than 31, but then 31 is less than 110, which follows it. So you can say that initially the list is unsorted, that is, neither you can say that the given list of numbers have the numbers in increasing order or decreasing order. We'll arrange this list in increasing order by using insertion sort. In the process of sorting the list, we'll be able to have a glimpse of what insertion sort is, or what are the various steps of insertion sort. So friends, in this particular case, what we do? We pick up the numbers from left towards right and we place them at their relative position with reference to the earlier sub-sorted list. For example, initially we'll take the number 80, but because now 80 is the only number under consideration, it is already sorted. You can say we take a sort of sub-list of the given list in which there is only one element, namely 80. And because 80 is the only number, there is no comparison because there are no other numbers, and therefore if we take the sub-list consisting of single element 80, it is already sorted. Now what we'll do? We'll go to the next element. Please look at the slide. In the given list, the second number is 32. Now what we'll do? We'll compare 32 with 80. And because we are arranging or sorting the list in increasing order, therefore we'll like 32 to come before 80. So what we'll do? We'll compare 32 with 80, and then if 32 is not more than 80, that is, it is not its right position, then we'll exchange. So in this particular case, what happens? Because 32 is lesser than 80, therefore 80 should be on the right hand side of 30. What we'll do? We will first of all move the number 80 to the, we'll store 32 in some position, move the number 80 to the right, that is in the position of 32, and then, because now at this stage 80 is in the first position as well as second position because of the copying, and because we have already saved 32, now we'll copy the saved 32 number in the first position. So at this stage we had a sublist of the given list, namely of the two elements 80 and 32. And in that we compared the last number with the earlier numbers, and whatever the earlier numbers, it is comparatively less, we'll move them to the right, and whenever the first number we come across for which it is greater, we'll replace. So this is the procedure in brief. Now once the list of 32 and 80 is in a sorted order, we consider the next element, which is in this particular case 31. So friends, what I have told, that now the list under consideration is the list in sorted order 32 and 80, and we have to find out the right position for 31 in comparison with the earlier sorted sublist, that is the list of 32 and 80. So what we'll do? We will compare 31 with the first element now in the list, that is 32, and we know that 32 is more than 31. Then what we'll do? All the elements in the list, sublist, will be moved one position to the right, and the first position, which will be actually having two, first and second position, both are having the same value. Now the first position will be replaced by the latest new entry 31. So at this stage we have got a sublist which is already sorted, having three elements 31, 32 and 80. And now we'll pick up the next element, which is 110. And again what we'll do? We'll compare the elements one by one. And the best way of comparison is we better compare from the last element. That is 110 is compared with 80. And because 110 is more than 80 and 80 is more than the earlier elements, Therefore 110 must be greater than equal to all the elements of the list. What does this mean? This means 110 is occupying the correct position vis-a-vis the earlier sorted sublist, because the earlier sorted sublist consists of 3 elements in ordered fashion, that is 31 followed by 32 followed by 80, and 110 being greater than 80 is relatively in right position, that is it should not be exchanged. That is, now after this step, the sorted list contains 4 elements, namely 31, 32, 80 and 110. Once this sublist is already sorted, we pick up the next element, and the next element is 50 in the initially given list. What we do? We will compare it with the last element, which was 110, and because 50 is less than 110, therefore 50 cannot remain in its original position, rather it has to be on the left. So what we will do, we will copy 100, we will save 50 in some location and copy 110 in the location earlier allotted to 50. So 110 will be occupying 2 positions, that is 4th and 5th. Then we next compare 50 with 80, and again we know that 80 is more than 50, that is the relative position of 50 is to the left of 80. So what we do? We move 80 to the location which was earlier occupied by 110, but we know already 110 has been copied in the 5th position, which was earlier occupied by 50, and 50 has been saved in some other location. Now next we move to compare 50 with the next element to the left, that is 32, and we know that 50 is greater than 32, that is, now we have found out the right position for 50, that is the 3rd position is the appropriate position for 50, because 50 is greater than 32, that is 50 should occupy a position to the right of 32. And because already 80 is copied in a position which was earlier occupied by 110, therefore we can move 50 to the current the position which was earlier occupied by 80, and in this way we will be getting a sorted sublist consisting of 31, 32, 50, 80 and 110. After having this sublist, we go to the next element which is not yet compared with any of the elements, that is, we go to the element 40. Again we compare 40 with 110. We know, first of all we will save 40, then we will compare 40 with 110. We know 110 is more, therefore it should come to the right of 40, therefore 110 is copied in the position in which initially 40 is there. So 110 will be in 2 locations. Then 40 is compared with the next element on the left, that is 80. Now again 80 is more than 40, that is 80 should be on the right of 40. So what we do? We copy 80 in the location which was earlier copied by 110, occupied by 110, and we know 110 has already been copied in the position right to it. Again 40 is compared with 50. But we know that 50 is more than 40, that is 50 should come to the right of 40, that is we again vacate the position of 50, current position of 50, to go to the position of 80, and in this way now 50 will occupy the position of 80, 80 will occupy the position of 110, and 110 will occupy the position earlier or initially occupied by 40. Now next we compare 40 by 32, and in the comparison we find that because 40 is greater than 32, so it should occupy the position right to 32, that is we have reached the right location for 40, that is now we copy 40 in the location currently occupied by 50, and we have already saved 50 in the location to its right. And because all the numbers which are there in the list before 32 are already less than or equal to 32. Therefore, we have again a sorted sublist consisting of 31, 32, 40, 50, 80 and 110. And because no more elements are left in the initially given list, therefore the last line contains a sorted list. So friends, this description with an example briefly explains the method of insertion sort. Now we will formalize this in the next slide. Please look at the next slide. The next slide says that we are given n numbers in some order A1, A2, An, and we have to sort it according to insertion sort, in which what we do, we will be picking up first A2 and will put the sublist A1, A2 in proper order by comparing and shifting to the right if required. Then we'll pick up the next element A3, then next element A4, and in this way the sorted list will be enlarged. So what we'll be doing, we will not pick up A1 as we did in the previous case. In the previous case we picked up 80, but you know a list of single element is always sorted. So we'll not pick it up and compare with the other elements because there is no other element. So we'll start our comparison with the second element. So please, so we'll start j is equal to 2 to n. J indicates the element which is under consideration for comparison with the elements which are already sorted. And we start the comparisons from the first element as we did in the previous case, that of we compared 32 with 80. And once the list 32, 80 is already sorted, then we picked up the three elements, that is j is 3. But again the comparison started from the other elements. So in this particular case, while we begin I is equal to 1. And while the new number, that is aj, is greater than the number in the list, what we will be doing, we will be shifting to the next number and we will go on comparing the new number with the elements in the given list till we find out a number which is already greater. So what would happen? Once we find out a number greater than the number which is being compared, we will store the number, save the number, which is the new number, which is being compared with the earlier sorted list. And now one by one we will be shifting the elements to the right. And finally the place where aj, the new number, has its right position, it will be copied, and this will give a larger sorted sublist. So this is basically the algorithm. So the algorithm can be thought of in two parts. The first part is by comparing the numbers, the new number with the earlier list, and find its right position. And once the right position is found, then we start the process of copying. We may go back again to our example. In this particular case, for example, we have already the sorted list of 31, 32 and 80. So what we do? We pick up the next element, which is 110. Now 110 is first of all compared with 31, then 32, then 80. And we know because it is 110 is more than or equal to all of these, therefore the right position for this is there. But once it is sorted list, we pick up 50. And again 50 is started being compared first with 31, then 32 and then 80. But once we reach 80, we know that 80 is more than 50, then we start. First of all, save this number 50, then we shift 80 to the position of 50. And then we start shifting all the elements to the right till there is the numbers start becoming less. And in this way we will be getting the next line. For example, 50 is first compared with 31. 31 is less. Therefore, it must be compared with the next number. Again 50 is compared with 32. Again 32 is less. Therefore, we can shift to the right. And then we have 80, but 80 is more than this. Therefore, 80 must be moved to the right. all the elements to this one and this. This briefly explains the method of insertion. And this is the algorithm is given here, which can be coded into a programming language which can be understood and executed by the computer system, and will give the right answer if you give any list of integers for comparison and sorting, please. Now we will be discussing bubble sort. Well friends, in insertion sort, one thing you found, that repeatedly the number 31 is being compared with every element. The number 31, which is the least element in the list, will be repeatedly compared with every new element. So unnecessary comparisons are there. And this is why there are other sorting algorithms which are required for the purpose. Bubble sort is another algorithm for sorting a given list which is not already sorted. But in this particular case, what we do, that whenever we compare a pair of adjacent numbers, and if they are not in proper order, they are exchanged. And then we go to the right one place, again compare a pair of new pair of integers. If they are in their appropriate comparative positions, then nothing is done. If they are not in the appropriate comparative position, then those are exchanged. This is the basic idea behind bubble sort. It is just like a bubble in the water which travels in a way. The bubble sort is named. We will be able to explain the method again through an appropriate example. The unsorted list will remain the same, and therefore please look at the next slide. Again we have, please look at the slide. Here again we have a list. Initially given 80, 32, 31, 110, 50, 40. Friends, you can see the given list is not sorted either in increasing order or decreasing order. Our purpose is to sort it in increasing order. So as I mentioned earlier, we start with the leftmost pair of elements. That is in this particular case 80 and 32, which are made bold in the first row. And we compare. And through comparison we know that because we have to arrange the numbers in increasing order, 32 should be on the left of 80. So what we do, once we found that 80 is not in the right position vis-a-vis 32, we exchange them, and after exchanging we will be getting 32 in the first position and 80 in the second position. Now we will go to the next pair. The next pair consists of 80 and 31. Again we compare the two numbers, and if these two numbers are not in relatively correct position vis-a-vis in increasing order, again we exchange. So in the second row, the two numbers which are shown in bold, that is second element and third element, they are not in appropriate increasing order, therefore they are exchanged. 31 is brought in the second position and 80 is brought in the third position. Again we take the next pair of elements, that is the elements in third and fourth position. In third and fourth position, in the third row, the two elements are 80 and 110 respectively. And we know 80 and 110 are relatively in correct position vis-a-vis increasing order. Therefore, in this particular pair, in the case of this particular pair, we don't do anything, we don't do exchanges, because they are already in appropriate order. So what we'll do, in the fourth row, now we'll be comparing the next pair of elements by taking the element to the right. That is, the two elements under consideration are 110 and 50. And we know that for the purpose of increasing order, 110 and 50 are not in correct order. What we'll do? We'll exchange these. And after exchanging, we'll be getting 50 occupying the position of 110 and vice versa. and we get the list which is given in the fifth row, that is 32 followed by 31 followed by 80 followed by 50 followed by 110. Please see, the whole list is not correctly sorted. You can see 32 is followed by 31, which is not the correct order. But at least one thing is visible, that the one number which is largest is going towards the right. So finally 110 and 40 are compared, because 40 is not in the right position vis-a-vis 110 with respect to increasing order. Therefore 40 occupies the position of 110 and 110 occupies the position of 140. Now in the last row, at least one thing has been done through in this repetition of 5 or 6 steps, that 110, which is the largest number in the list, finally must occupy the last position. However, the rest of the elements, that is 32, 31, 81, 50, 40, are again not in proper increasing order. But this is sure, that if we compare a pair of adjacent elements and bring the bigger of the two to the right and through exchanges, etc., ultimately the largest number must come to the final position. Once this is done, now the last element is 110 or is the largest number. Now we need not take into further consideration so far as increasing order arrangement is concerned. So what we'll do, now we'll consider in the next step, we'll repeat all these steps, but for the sublist which consists of one element less, that is 110 is dropped for further consideration. So the sublist 32, 31, 81, 50, 40 will be considered. And you can see, after repetition of 3 or 4 comparisons of pairs, we'll be getting the largest element in the remaining list, that is 81, in last but one position. At every step, the list which is to be considered in the next iteration is becoming at least one number, less in size. So now in the next iteration we'll be considering the sorting of the list 32, 31, 81, 50 and 40. Please continue looking at the slide. So the sublist of 5 elements is considered. Again the pair of elements, first 2 elements pair is taken into consideration, and as we know 32 is more than 31, that is 32, 31 are not in proper relative proper order, therefore we must exchange them, and after exchange we will be getting 31, 32. Next what we do, the 2 bold numbers in the top row, that is 32 and 81 are compared, and in this particular case you know that 32 is less than 81, that is 32 and 81 are in relatively correct position, therefore no exchange, no further action is required vis-a-vis this pair of 2 numbers. Then what we do? Next we consider next pair of elements, that is 81 and 50, and we know 81 and 50 are not in proper ordering, and whenever a pair of numbers is not in proper order, what we do? We exchange the 2 numbers in their relative positions. So the 50 occupies the position of 81 and 81 occupies the position of 50, and in this way we get a 31, 32, 50, 81, and then we consider pair of elements by adding next element to the right, that is 81 and 40. And we know that 40 is not in the correct position relative to 81, therefore again 81 and 40 are exchanged, and finally we, after these iteration of 4 iterations, we get 81 in the last position of this sublist. Therefore what we do, now we will be repeating the same sequence of steps on the sublist just of 4 elements, that is 31, 32, 50 and 40, and again we will be comparing the first pair of elements, that is 31 and 32, and we know 31 and 32 are in relatively correct position, therefore no exchange, and therefore after this step we will be getting the sublist 31, 32, 50 and 40. What next we do? Again we move to the right one element, consider the pair 32 and 50, and we know that 32 and 50 are again in relatively correct position, therefore no exchanges are taken place, and we reach the next row, that is finally we consider the pair of numbers 50 and 40. And we know that 40 is less than 50, that is 50 and 40 are not in relatively correct order. Therefore, we exchange these two elements and we get 40, 50, that is the sublist, which is after removing the last two elements consisting of two largest elements in proper order, we drop 50 in this particular case, and now the sublist, which may not be in properly sorted order, consists of three elements 31, 32 and 40. So what we do? Again we repeat similar sequence of steps, that is we take the leftmost pair of numbers which are 31 and 32 in this particular case, we compare them, find out whether they are in proper order or not, and if they are not, we exchange them. So friends, in this particular case 31 and 32 are in proper order, therefore no further action is taken vis-a-vis this pair of elements, and therefore we reach something like that 31, 32 and 40. Next what we do, we move one element to the right and again consider the pair under consideration is 32 and 40. Again we know 32 and 40 are in relatively correct order, therefore no exchange takes place. Finally in the last what we get 31, 32 and 40. Because 40 is the largest element, we leave it from further consideration, though the list 31, 32 and 40 is already sorted, but we don't step the process because the process requires that drop the element 40 from consideration and repeat the process. So again we have to consider the sublist consisting of two elements 31 and 32 and repeat the process. But you know, in the last step what we will do, we will compare 31 and 32, and if they are not in order then we will exchange, but fortunately 31 and 32 are in proper order. So once 32 comes in the its final position, we are left with one element, and once we are left with single element, the process cannot be repeated because the process which we have explained just now can be repeated when a pair of numbers is left, because no pair of numbers is left for comparison, therefore the process terminates. So friends, in brief, what you are doing, you are comparing adjacent pair of elements starting from the leftmost pair and then exchanging if they are not in proper order and go on like this one. Repeating this process in the first round, you will be getting the maximum number of the whole list in the rightmost position. You drop it from further consideration, consider only the sublist obtained by dropping this element, repeat the same process, and this is how this bubble sort works. Formally we may say the algorithm bubble sort can be written like this: procedure bubble sort A1 A2 AN, and what we will do for the topmost element we will be repeating from 1 to n minus 1, that is and in the second row we will be comparing from 1 to an whenever the two elements aj and aj plus 1 are not in proper increasing order, then we will be exchanging, otherwise we will not be doing, and every time we will be increasing the pair to be considered to the right. And this is actually what is known as bubble sort. Friends, with this discussion of bubble sort, we go to the next algorithm, which is called selection sort. The selection sort is another way of sorting an algorithm, a given unsorted list. In this particular case, we saw in the case of bubble sort that in the first iteration 4 or 5 steps, ultimately the largest element reached its final destination. But you see how 110 reached its last position. It was after a number of comparisons and iterations. So it is in the case of selection sort, we every time compare the elements and find whatever is the largest out of the sub-list so far considered, save it in a separate location, and then we compare a new element with this so far maximum, and if the so far maximum is less than the new element, then the new element becomes the new maximum, and like this one. So in this procedure, what is the advantage? That the maximum element is found just through one iteration and not more than one iteration. That is the basic idea of selection sort. Again, we will be explaining this through an example. So friends, for this purpose, please look at the slide. Again, we are given a list. And in this particular case, as I mentioned, what we will do, we will create a new variable max, and max position, that is a position which contains the maximum element. And we will go on noting the maximum so far and the position which it occupies, and we save it. So that is the basic idea of selection sort. Let us consider an example to explain it. Friends, here again the example is 80, 32, 31, 110, 50 and 40. So what we do? We make the first element as the initial maximum. That is, we assume the very first element is the maximum among the list of numbers. And what is its position? The position is 1. Now, by and by, this new variable max is the contents of it are compared successively with the elements to the right. And whenever the element to the right happens to be more than the current maximum, then the new number is made the current maximum, and so on and so forth. So what we do? Initially 80 is the maximum, and this maximum is compared with the next number 32. But 32 happens to be less than 80, therefore the current maximum still remains 80, and its position is 1. Again we go to the next element to the right, that is 31. Again we compare 80 with 31, and again 31 happens to be less than 80, therefore our current maximum still remains 80. Then we go to the next element, that is 40. Again 80 happens to be more than 40, therefore the current maximum at this stage is also 80. And the position of the maximum number so far is 1. Again we go to the next element, which is 50. Again 50 happens to be less than 80, therefore the current maximum so far is 80. And the position of the current maximum is 1. Now we go to the next element. The next element happens to be 110. And we know 110 is not less than 80, therefore our current maximum now becomes 110. And the position of 110 is 4 now. The current maximum is 110 and the position of the current maximum is 4. What we do? At this stage, the last element and the element which is maximum are exchanged, because we know their positions, and therefore through this exchange what would happen? 40 will occupy the position of 110 and 110 will occupy the position of 40. And ultimately after this iteration you will be getting 110 in the final position. You can see that 110 which is largest occupies the right position after only one iteration of comparison of the numbers in the given list. So that is the advantage. Now the rest of the process is repeated with the sub list. So friends, we will discuss these sorting algorithms in the next half. Thank you.